Welcome to another Lob's Math video lesson. This lesson is on the Triangle Midsegment Theorem. The midsegment of a triangle is the segment that connects the midpoints of two sides of a triangle. We have the midpoints x, y, and z, which are the midpoints of each of the three sides. If we connect x and y, we get the midsegment. Every triangle has three midsegments, so we also have the midsegment from y to z and the midsegment from z to x. The three midsegments form what is called the midsegment triangle. Now if we look at this midsegment yet again, we have the following thing that we could prove is that the midsegment is parallel to a side of the triangle. The proof for this is typically done in a coordinate proof, but we could prove that statement that they are parallel. So we've got the segment XY is parallel to the side PR. We also have another thing we could prove. Again, the best proof for this is in coordinate proofs, is that the midsegment is half the length of the parallel side. So the length of XY is equal to half that of the side PR. But that also means that the side PR would be twice that of the midsegment. Now, these two statements put together form the Triangle Midsegment Theorem. Again, it's provable. It's a theorem. We use it a lot. The proof is typically done as a coordinate proof. Because of the Triangle Midsegment Theorem, because we have these midsegments that are parallel, we end up being able to show, this is not part of the midsegment theorem, but because of the midsegment theorem, we can show that there are some angles of equal measure. So if we look at, and the big question would be, why are they? So we've got this triangle, PQR, and we have a midsegment XY, which is parallel to the side PR. And we note that we have some corresponding angles, and so that's why we get some congruent or angles of equal measure. But we also have another pair of corresponding angles, so we have that. This is true for all three midsegments, because the theorem, the midsegment theorem, is true for all three midsegments. So we're also going to get a lot of parallel lines, so therefore more corresponding angles. So if we draw in the next midsegment, the midsegment XZ, and the midsegment theorem says that it's parallel to the side QR and that it is half the length of the side QR. And we also have a pair of corresponding angles that are congruent. We have another pair of corresponding angles that are congruent. And then we have the third midsegment, which is parallel to its opposite side. So the midsegment YZ is parallel to QP, and the length of YZ is half that of QP. And once again, we're going to have a pair of corresponding angles, which would therefore be congruent, and another pair of corresponding angles, which would therefore be congruent. So the midsegments end up dividing the large triangle into four smaller triangles. And the first triangle we get is the triangle XYQ, which I highlighted in blue. The second triangle is the triangle PXZ, highlighted in green. The third triangle is the triangle ZYR, highlighted in orange. And the fourth one was our midsegment triangle, triangle YZX. There's an important conclusion we can make about these four triangles, and the big question will be why. Why can we make that conclusion? And that I want you to be prepared to prove in class. So make sure that you are paying attention to what's congruent and why, so that you can make a conclusion about these four triangles and prove that in class. Let's look at an example of how we can use the Triangle Midsegment Theorem for computations. So we have this triangle with its three midsegments, and here's some data. We have the measure of angle PMN is 26, the measure of the angle JLK is 102, and the measure of the midsegment MN is 6.2, and the measure of the midsegment JK is 15.4. What we want to find is the measure of the segment MP, the measure of the segment LK, and the measure of the angle PNK, all of which are highlighted in yellow in the diagram. For part 1, to find the measure of MP, we note that MP is a midsegment, so the midsegment is equal to half that of the side JK. We see that we have the measure of JK, so we're going to use substitution. Then we'll simplify, and we get that the measure of the angle MP, measure of the segment MP, is 7.7. For part 2, we want to find the measure of the side LK, and it is the whole side, which we know is twice that of the midsegment. So we are going to use substitution here. We plug that in. Then we'll simplify, and we get that the measure of the side LK is 12.4. For part 3, for the angle, this takes a little bit more work. We have to go to the diagram, because what we have to do now is we need to mark the congruent angles in the diagram, thinking about those corresponding angles. So we note that we have 3 angles, angle L, angle JMN, and angle NPK, that are all congruent. And similarly, because those are congruent because of their corresponding, in similar fashion, we find that we have these 3 angles, the ones that I just put 3, the green double arcs in, and we have 3 more congruent angles, again because they all correspond. They're purple with 3 arcs in them. But the question is, what about this interior triangle, this mid-segment triangle? We don't have any of the angles marked there. Well, in this previous question up here, I was asking about, what can you conclude about all 4 of those triangles? And what we can conclude is that all 4 of those triangles are in fact congruent. We can use the side-side-side triangle congruency theorem to prove it. There's several other theorems that we could use, but that would be one easy one to use. Side-side-side triangle congruency theorem to prove them all congruent. And because they're all congruent, I can use corresponding parts of congruent triangles are congruent to prove the measures of the 3 angles in the mid-segment triangle are congruent to the angles in the other 3 triangles as well. And so I've marked them with their corresponding angles, with the 1 blue arc, the 2 green arcs, and the 3 purple arcs. So in this diagram, we now see that wherever I see 2 green arcs, I can put 26 degrees, and wherever I see 1 blue arc, I can put 102 degrees, but nowhere in this diagram does it tell me what 3 purple arcs is equal to. But I do have the Triangle Sum Theorem that says that unknown arc, that unknown angle, plus the 102 and the 26 must add up to 180 degrees. So adding them together and subtracting, simplifying, we get that the measure of the angle PNK is 52 degrees. So this is how we can use the mid-segment theorem in a triangle to do a lot of different computations. And now for your viewing pleasure, here's a sped up version of the mid-segment theorem in triangles and how it's all constructed.